Okay, welcome to the class of Physics 202. We're talking about isotopy this time. When we mention isotopy, what is meant by isotopy? Isotopy is a phenomenon whereby atoms of the same element differ with their atomic numbers. We all know that the atomic number can also be the proton number, or is also the number of protons in the nucleus of the atom. So X, the atomic number is Z, and the mass number is A. We denote the atomic number as Z here, subscripted, the mass number superscripted, and this is the atom X. It might represent any atom. So I'll be making some examples here. Here is a hydrogen atom of 1, atomic number, mass number 1, hydrogen 2, and hydrogen 3. This is the atomic number. It is unique to all elements according to Dmitry Mendeleev. So these atoms differ with their own mass numbers, and that differences are as a result of something, and that is as a result of difference in the neutron number n. We all know that the mass number A is equal to the atomic number plus the neutron number. So if this is hydrogen atom, that is called the protium, the first isotope of hydrogen, with about 90-something% in abundance. So the mass number is 1, right? The one at the top. 1 is equal to the atomic number 1 plus the neutron number. It is obvious that the neutron number here is 0. That means the protium hydrogen doesn't have any neutron in it. It doesn't have any neutron in its nucleus. Now look at the second hydrogen called the deuterium. And this is the common hydrogen we all know. So look at the deuterium here. The deuterium is mass number 2. That is 2 is equal to the atomic number 1 plus the neutron number. Here the neutron number is 1. That means this deuterium has 1 neutron in its nucleus. This is used to form water, heavy water, D2O, heavy water. So the next one is the tritium, H31. So the tritium is having 2 neutrons, which is like this. 3 is equal to 1 plus n. So n equals 3 minus 1, which is 2. That means the number of neutrons in this tritium is 2. Tritium is used in nuclear reactors. So these 3 things are called isotopes. And the phenomenon occurring between them is called isotopy. Now, isotopy is as a result of something. What is that thing? A difference in the number of neutrons in the nucleus of the atom. That is what brings about isotopy. So there are some atoms, there are some elements that do not have whole numbers as their own mass number. The mass number of chlorine is 35.5. Chlorine 1735.5. There are many examples of isotopes. Let's check 1 or 2 of them before calculating the mass number of chlorine. So chlorine can exist in the universe as in the earth as 1735, chlorine 1737, oxygen can be having 18.8, oxygen can be having 16.8, carbon 12 exists, 6, carbon 13 exists, 6. So sulfur 32 exists, sulfur 30 exists. So all these are what? They are isotopes. These are 2 isotopes of the element chlorine. And this is actually one of the modifications of the Dalton's atomic theory that says all atoms of the same element look alike in every aspect, while atoms of different elements differ in every aspect. But now this is an atom of chlorine, this is another atom of chlorine, but they are differing in the aspect of neutron now. That means the theory has been modified, that all atoms are the same in all aspects. No, they are not the same in all aspects. Because of what? Isotopy. So with this now, we're having isotopes. So how do we now arrive at 35.5 as the mass number of chlorine? In the universe, this exists as 75%. This exists as 25%. This oxygen exists with more than 90%. This exists with less than 10%. This carbon exists with up to 99%. And this is less than 1%. You can see 90, 99. That is very, very dominant. We can just get rid of these ones that are less than 1 and less than 10. But here, this is 25, this is 75. We can see 75 is also very much dominant, and 25 is very negligible. No, 25 is not a negligible measurement. So we have to at least do 1 or 2 calculations to bring about the decimal number as the mass number of chlorine. And that is why the mass number of chlorine is not a whole number. That is because of isotopy. So this is 75%. 75 over 100, that is 75%, right? Times the mass number 35 plus, this is 25. 25 over 100 times the mass number 37. So 25 will go here 3 times. 25 here goes 4 times. 25 here 1, 25 here 4 as well. So this is 3 times 35, 105 upon 4 plus 1 times 37 is 37 upon 4. Doing the mathematics here, this is equal to 26.25 plus 9.25. So this is equal to 35.5, which is the mass number of chlorine. So this is how the mass number of chlorine, which is not a whole number, is gotten, 35.5 as the mass number of chlorine. So we now write chlorine this way, 35.5, 17 Cl. So that is how the mass number of chlorine is gotten. It is because of a phenomenon called isotopy. And these two things are isotopes of chlorine. Thank you.